So today will be a discussion is a very simple topic that is in programming C concept. So first of all we decided that what is my program concept. Program concept is that simple of writing of program and execution in the C programming concept. But what is the hidden part? Hidden part is how the program will be run and executed and how to do it. Okay. So in case of that formal language of automata theory, so your consideration one example, that consideration example is that design finite automata which divisible by all the string that means I am just designing a finite automata machine which is divisible by all the string that is 2. That means I am giving some number of binary number of string like 2, 4, 6, 8, 10. Those are divisible by 2. That will be I am designing finite automata. So another one concept is in our program, suppose I am giving the input file is 2, so my result is it's divisible by 2. I am giving the 4, that means result is divisible by 2. But what about the 3? What about the 5? It's not divisible by 2. That is my output. So I am just giving the diagram. The diagram to define that how the program will be run. Okay. So first, if you define that, I am just taking some elements. That is 2. My string is that 6, 8, 10, 12, 14, likewise, and that string is defined infinite string. Clear? To find the binary concept. The reason is that system only understand the binary number, that is 0 and 1. So that's why we are converting each and every number in binary from 1. So 2 is having that 0, 1, 0. 4 is having that 100. 6 is having that 1, 1, 0. 8 is having that 1, 4, 10, 0. 10 is having that 1, 0, 1, 0. Likewise, we have practice. This is the first objective here. This is my first requirement. Then I go for the designing the edge. Right? So what is the designing procedure? First of all, previously already I am saying that before the finite automata machine, we are having some tuples M, Q, that will be sigma, Q0, del function, F. So Q is the number of state, sigma is your input alphabet, U is your starting state or initial state, del is your transition function, F is your final state. So in that particular case, sigma I know that is 0 and 1. How can we get that? That is the depending upon your binary string. It is the combination of 0 and 0. So my input alphabet is 0 and 1. That is defined. So Q and F del Q0. So I am just taking one state diagram. That is the naming is Q0. So I am just satisfied designing one machine that satisfies all the string. That is my optimizing part. I never draw for that each and every string. That is not an optimizing string. I design only one string or one state of diagram that accepted all the string. So I am going for my first string. What is the value here? 0. Next is 1. Next is 0. That means this third 0 I am reaching at final state. Starting 0, that is going to define initial state. So that 100, 100, 110, 1 10, 0, the concept is that starting state will be same, final state will be also same. That is my optimization rule. If it is final state may be vary depending upon the criteria. But initial state that never vary. It is single one. That is the concept. So next I am giving 0. So I have a two part, either self loop otherwise transfer to another part. Only two options. I am giving a self loop, otherwise I am giving another input symbol getting to be another output state. Otherwise, no option. So first I choose the first one because it is all are hit and trial method. Fine. So it will be 0 here. Next will be 1. Okay. 0, 1. Next ended with 0. So best optimizing thing will be I am giving here 0. So now this is my final state. Okay, I am just erasing this one. Last we will define the moving state. So here it is 0, here it is 1, and here it is 0. Just remind it, this one my final state. Just a mark. Next, 1, 2 times of 0. So here it is 0 will be starting, 1 it can be also starting. So okay, no issue for me. So 1, you next step, and next step self loop means n number of times will be repetition. In case of self loop, it is n number of time of repetition. That means previously I am understanding that this is the cross. That means this is the cross. This cross will be defined 2 times to n times. Defined. So self loop defined 0 times or n times. Okay, fine. Next. So it will be also satisfied. This will satisfied. This will satisfied. 1, 1, 0. So 1. But next one will be defined. So I have a one option here. I am just coming to here. So I am giving that because we are having the optimization things. So if I am having that next step, you have a possible. Maybe you can draw it, but this more step. Try to optimize it within the step. That is, will be having 1 here. So 1, 1. This will be 0. Fine. This string also satisfied. Next 1 time, 3 times 0. This is also satisfied. 1, 0, 1, 0, 1 times 0. Next time 1, next time 0. But this one is the final step. Again I am having my string starting from 1 and move to here. Clear? Now it is 0 and one self loop here. That means here it is suppose Q1. Here it is again Q1. Again 1. 1 means this one. So I am now Q0. So now I am here Q0. So this is your initial state. My final state will be first. This one. The concept is wrong. Maybe 2 is satisfied, maybe 4 is satisfied, maybe 6 will be satisfied, maybe 8 will be satisfied, but 10 will be not satisfied. Fine. So this method is wrong. Now again you have to be changed. This is purely hit and trial methods. So in my point of view, so it is my experimental points. Trick is that you have to apply this trick. Try to initial state as a final state. This is my first step. Clear? Next, I am draw directly del option by transition function. What are the input state? 0 and 1. Clear? What are the input state? 0 and 1. What are the total number of state? It's 2. If my question is divisible by 3, total number of state 3. If you divisible by 4, total number of state 4. If you divisible by n, that is n number of state. That is gate possible. Clear? So it is the 2 states. So I am here Q0 and Q1. Clear? Fine? Clear? So simple you have to define. How can you define it? Here it is remainder is divisible concept. Na? We are going for the remainder option. If it is divisible, what is my remainder? 0. If it is not divisible, what is my remainder? Is 1. In case of 3, 0 is the divisible, 1 and 2 is a not divisible case. That means this Q1, this is Q2. It is a not a final state. Q0 is your 0 by divisible state. So it is a final state. 1. Q1 is a non-final state. 0 is a divisible, so it is a final state. That's why I am applying this trick. Why I am